Let's talk about vectors and what they represent. They are, well, they're basically like matrices. It's a 1 by 2 matrix. You have one row and two columns. Notice I'm pointing at that -2, 3 right there. And they imply the direction you're going and the magnitude with which you're traveling. So let's actually begin. I'm going to grab a ruler. Grab this handy dandy NC State magnifying glass ruler. Aren't you impressed? And we're going to graph this, and it's going to represent the direction we're going and the magnitude we're going. So when we get to a word problem, it'll make a little more sense. But here it goes. 3 times. So I'm going to ignore the 3 for now. I'm just going to do one of them. So we're going to do -2, 3. We're going to graph that. So -2 and then 3. So here's our first vector. There it goes. There it is, right there. Here's our first vector. Well, we have 3 of them. So this, I don't know what it represents, but maybe we were rowing our boat for 3 hours. This is the first hour, and then another hour, and then another hour. So we're going to connect them end to end. So at the arrow of this one, we're going to do -2, 3 again. So we're going to go back to the left 2, and then up 3 again. There's our second one. And then we have one more, so -2 and up 3 again. There's our third one. These are kind of self-explanatory. You know how to plot points, so you know which directions to go. Now, you could have went ahead and done 3 times this and 3 times that, and you would have had -6 and +9, and you could have gone back 6 and up 9. It works that way too. Well, from the end of this one, we're going to add 5, 1. So 5 is the horizontal, that's our x. So we're going to go +5, 1, 2, 3, 4, 5, and then up 1. There it is. So from the end of this vector, we're going to go over 5 and up 1, and we now have our ending point. And our ending point is right there, and we have to figure out where that is. Like, where is there? And that point is at -1, +10. So my final vector is at -1, +10, which really means this. I was traveling -2, 3, and then it happened 3 times for whatever reason. And then we had some other vector that was dealing with this whole process, and we were going 5, 1. It might be like rowing your boat, and then there's the wind and that sort of thing, and they kind of counteract each other, and you end up somewhere other than the direction you were rowing. It's like that. Now, if you want to get technical about it, we could, so like from the origin, we could draw this. There we go. So there's our resultant vector. It's -1, +10. So we're going to do the same thing here and here. We're going to go a little bit faster on these because I think it's self-explanatory. So if you know what you're doing, feel free to just have fun, do this. Now, you're probably thinking, couldn't I just do the math up here? And the answer is yes, you could, and we will in a minute. So let's start with 7, -5. So 1, 2, 3, 4, 5, 6, 7, and then down 5. There's that. 7, -5. And from the end of this one, we're going to do 2 of these. We're going to do 1, 3. So 1, 1, 2, 3. 1, 1, 2, 3. There we go. And so now we will connect the origin to the end of this whole thing. So we had 1 of those and 2 of those. So from the origin to here, have this. So 9, 1. You just have to find out where it ends. You don't have to draw that resultant vector to find where it ends, but that is the resultant vector. Like this is the result of this vector plus 2 times that vector, and it is 9, 1. Okay, let's do this one, and then we will be done with this first section. So -4, 3. There's our first one. I'm not going to use a ruler on this one. I can draw straight lines without a ruler. -4, 1, 2, 3, 4. 1, 2, 3, and we have 2 of those, so we've done those 2. Now from here, we're going to do 4 of these. We're going to have 2, 1, 2, 1, 2, 1, 2, 1. We're going to do that 4 times. So 2, 1, 2, 1, 2, 1, 2, 1. There it is. And so 1, 2, 3, 4. There it is. we now have our resultant vector going from the origin up to here, and it is at 0, 10. Now, by the way, 0, 10. There we go. By the way, we could have done this by hand, and let me show you very quickly what that looks like, and I'm sure you're aware of this process. But here goes. We could do 2 times negative 4 and then 2 times 3, so that'd be negative 8, comma 6. And we also have 4 times 2, 4 times 1, so 8, comma 4 is that. And we're going to add those together. And so negative 8 plus 8, we add the corresponding part. So we add the first number, which is the x, and then we add the second number, which is the y. So the first number, negative 8 plus 8, that'd be 0, and 6 plus 4 would give you 10. So that's how you do it by hand. So do you have to do it graphically? Well, yes, because I said so. Haha. All right, here we goes. Here we goes. Here we go. A ship is traveling on a path and magnitude represented by that vector, and the current is flowing at that vector. Each vector represents the hourly rate of movement. Write the vector that represents where the boat is at the end of 1 hour, 4 hours, and 1.5 hours. Now, I gave you a graph, but I'm not going to use it. You could if you wanted to. So you could be like, oh, 7, negative 3, and you could do it that way. I'm not, okay? I'm just going to do exactly what we just did up here on this one. So 1 hour, let's see. The first hour, I have rowed my boat. That's not a boat, it's a ship. I have traveled in my ship this direction in this magnitude. So 7, negative 3, if you want to see it graphically. And then I'm going to add that to what happens with the current. So I've pointed my boat in this direction, but the current's flowing in this direction. So I'm going like this, but the current's going like this. And so it kind of messes with the direction I'm really going. This one's super easy. So 7 plus 1, so 8. And then negative 3 plus 2 is negative 1. And that is it. So there's the first one. So this is where I am, the resultant vector, at the end of 1 hour. So notice, and there's really not much to notice here, but notice that there's a 1 here and a 1 here, that they weren't there, but they're understood. Okay, so if I'm going to do this for 4 hours, then I could do the same process and I'd put a 4 here and a 4 in the front here. But why would you do that? Like really, why would you do that? And here's why you wouldn't want to do that. You could, it's not wrong. But if I do this for 1 hour, if this is what happens after 1 hour, then after 4 hours, I'd multiply by 4. So 32, comma, negative 4. Dun, dun. Dun, dun. There it is. Okay, well, 1.5 hours. It's the exact same thing we just did. So this is my answer, assuming it's right, and it is. This is my answer for 1 hour, but I want this for 1.5 hours, so 1.5. So 1.5 times 8 is 12. 1.5 times negative 1 is negative 1.5. There we go. All right, let's proceed to the backside. And on the backside, they give you 2 vectors, and they just ask you to perform some operations on them. So this is going to be a lot like what we just did. I'm going to go very quickly on these. So negative u plus 1/2 v, they told you what u is, they told you what v is. You could type this into desmos.com/matrix. You could say that this one's A, and this one is matrix B, and then just type the appropriate things. It'll crank it out for you. Actually, graphing calculators will do this as well. I'm going to do it by hand because, honestly, by the time you type this whole thing in, most of these could be done. Actually, what I'm really going to do, I'll tell you what I'm going to do. I'm going to write them all out first, and then I'll do them. Okay, so what I've done is just write them all out. That's the tricky one. We'll deal with him last, of course. So everything's just written out in the place of u. I put this one in the place of v. I put this one, and we're just going to begin this process. So here we go. Negative 1 times 4, negative 1 times 6, and then 1/2 times negative 12, and 1/2 times 8. So we'll just distribute. We can do that first. So let's start with that. Negative 4, comma, negative 6. And then half of negative 12 is negative 6, and half of 8 is 4. And we'll add these together. And this is really doable in your head. Before you grab a calculator, you can do a lot of things in your head. Negative 4 plus negative 6 is negative 10. Negative 6 plus 4 is negative 2, and we are done with that one. Okay, let's move on. Let's not waste time. There is a subtraction here. If you want to kind of go old school on it, you can pretend like it's a negative 1. You could do that whole thing right there. It's like plus negative 1. Negative 1 times negative 12, negative 1 times 8. And so we'd have 4 and 6. That one didn't change. And 12 and negative 8. 4 plus 12, 16. 6 plus negative 8 would be negative 2. See how fast that is? Let's keep moving. Half of these, let's see, half of 4 is 2. Half of 6 is 3. A fourth of 12 is 3. It is negative though. A fourth of 8 is 2. And we'll add those together. I'm going fast, but I don't want to waste your time with stuff you know how to do. 2 plus negative 3 is negative 1. 3 plus 2, you better know what that is. There we go, there's 5. Okay, this next one's a little tricky because of the way it's configured. We have 3 halves times this entire thing, and this entire thing is u plus v. So let's do u plus v first. Let's deal with that first. That is the very first thing we should do. So we're going to have 3 halves, and then parentheses, or not, actually. 4 plus negative 12 is negative 8. I'll put in my brackets because we're still dealing with vectors. My pointy brackets. And then 6 plus 8 is going to give me 14. And now if you're like, why do I even have parentheses and the brackets? You don't have to have the parentheses at this point, but basically it's 3 halves times 8, 3 halves, or negative 8, 3 halves times 14. So 3 halves times 8, let's see, half of 8 would be 4, and then times 3 would give me 12, but it is negative. Still a vector. Half of 14 is 7. 7 times 3 is 21. There we go.